He doesn't get the Honeywell?
You serious? I think it's funny. I think it's funny that he's not even like on a normal day here at 8 o'clock. No. Like he strolls in around like 8:20 anyway.
That's funny. Okay, here we go. Properties. If you have an integral, notice if the bigger number's on the bottom and the smaller number's on the top, we can't do that. You have to flip it around, and if you flip it around, you just put a negative out front. So if you notice that the numbers are wrong, you have to flip it around and pull out a negative. Okay? It says, this is like the explanation. This is the book's explanation for this. It's a definition. Just know it. So don't ask me why. Yes, the bigger number always has to go on top. This one I can't explain to you. If we think about this as the area, right? If I'm going from A to A of any function, how much area have I included, no matter what the function is, if my interval is from A to A? Yeah, there's no area. Does that make sense? So that's why it's always 0. Also, a definition. I copied this straight out of the book. So
it's funny that they said also a definition.
I know. It's funny. Our book's kind of funny. You guys never read it, but it's funny. Constant multiple, we've had this one for derivatives, but it's also true for integrals. If you have a constant times a function, you can pull that constant out front and then actually do the integration or the area. And that's for any number k. Notice they use k, not c, because it kind of, we put c at the end. I do have to say some people forgot their plus c on their homework quizzes. I don't remember. But it's mystery Pop-Tart. This is kind of still a constant, right? I don't know. I guess they're giving you an example of this, right? This would be a constant of -1, so you could pull the negative out just because it's a constant. If there was a 3, you could pull the 3 out, right? So that's saying if k equals -1, then you just pull the negative out. Yes? Probably I'm not making you write these down. But our notes aren't very long. Sum and difference, we talked about this when we did indefinite integrals, but if you have a sum and or difference, you can just break them up as two different integrals. This one does come up a lot. I've seen a question like this on an AP test. This is my favorite word, additivity. I think of it as like the segment addition postulate of geometry. I'm sure you all remember that, right? Oh, yeah. So let's pretend that this was A, and this was B, and this was C. If I was talking about segments, if I was adding up, do you agree that if I add A to B up, and I add B to C up, that's the same as adding the whole thing up? That's the segment addition postulate. It says if you measure A plus B plus B plus C has to equal AC. It says the same thing with integrals. If you do the integral from A to B, find that area, and then you do the integral from B to C, that would be the same as finding the integral from A to C, where B is a number in between A and C. Does that make sense? Additivity. 6 is where it gets a little bit crazier. I feel like 6 and 7, I don't feel like they're ever going to ask you a question on 6 and 7, but it's in here, so I let me at least show it to you. It says the max-min inequality, if max f and min f are the maximum and minimum values of a function on the interval, then the minimum of f times your interval will always be less than the area of that actual function, which will be less than the maximum of that function. Yeah, or equal to, I guess, because it could be the actual value of it. And basically, think about if this is the entire area of the function, right, you're going to get that value. It should sort of make sense that if you looked at the minimum value, it should be smaller than the area, and the maximum value would be bigger than the area because you have the whole area. There's a question on your homework that tries to make you use this. It's the only time I've ever used this property is on that one question in this section, and I'm sure we'll talk about it to maybe make it make more sense. I say don't stress a lot about 5 and above. You need to know those. 6 and 7, don't stress too much. Yeah, kind of like the left and right endpoints, not endpoints. It would be like the minimum being the lowest value and the maximum being the highest value, right? How about this one? This one's even a little bit crazier, I think, but domination. It just means like implies. So what's this one saying? It says if f of x is bigger than g of x on the interval, and I feel like this one makes more sense than 6 to me. If you have a function that's bigger than another function, or greater than another function on the same interval, then the integral, or the area of that function, should be bigger than the area of the function, the other function. Does that make sense to you? To me, that one makes more sense. I probably would still do the integral to figure it out if I needed to, but if this function is greater than it, if it's higher up on the y-axis, it would make sense if this was f of x and this was g of x from the same interval, that the integral for f of x would be all of this, where the integral for g of x would just be the bottom part, like it would be a smaller number. And so then you could imply that if f of x is bigger than 0, then its integral should also be bigger than 0. Yes. That's the, okay. Yeah, like you could graph both of them and look at them, or if they gave you just a number here and not a function. Let's just say they said f of x is greater than or equal to 7. Like let's say they told you that. You could imply that the area of that would have to be bigger than 7. Okay, again, 6 and 7, not so important, but I want to at least show it to you. Okay, and there's a couple on your homework that we'll come back and talk about them. But what can we do with this now? Now I can give you problems like this, but they don't actually give you a function, and I can ask you if things are true using these properties. And this is the kind of stuff you're going to see on your homework today, which means there's not really work to show, it's just matching it up to a property and seeing if you can do it. And again, this is kind of stuff I have seen on the AP test before. So there's a lot of problems here. We're just going to do a step at a time. But notice they don't tell us what f of x is, but you have to use the properties to find the answer. So they're telling us that from -1 to 1 of f of x, that the value is 5. So the area is 5. From positive 1 to 4 of f of x is -2. And from -1 to 1 of a different function of h of x is 7. Using that, find each of the integrals if possible. And sometimes it's not possible, because sometimes we don't have a property that says we don't know for sure. So let's look at A first. A says find the value from 4 to 1 of f of x. Can we do that? We have 1 to 4. So I'm going to show you the work here, but you don't have to show me all this work on their paper. But could I say, if I pull a negative out of this, then I can switch these around and make it 1 to 4 of f of x? If that's that property, that first property I gave you. So if you notice that you can switch the numbers around, all you have to do is change the sign, really. So this would become negative of -2. Or you would just say, oh, I switched it around. It's the opposite of -2, which would be +2. What about part B? It says find the integral from -1 to 4. I'm going to write these down here. Could I do the integral from -1 to 4 of f of x? Because I have -1 to 1, and then I have 1 to 4. So I think that's the additivity one, right? Like you could say this would be -1 to 1 of f of x plus 1 to 4 of f of x. And because there's not a gap here where this one stops, this one starts, we can just add those two values together. We're not graphing. We don't know what we're graphing. We're just using the values that they give us. So we can say 5 plus -2 should be an answer of 3. Questions about this? Look at part C. negative 1 to 1 of 2f of x plus 3h of x. This is using the constant multiple rule and the sum and difference. Negative 1 to 1 of f of x, we have that. Negative 1 to 1 of h of x, we have that. And so you could just, again, I don't know how much work you're going to show here. On my paper, I wouldn't really rewrite it. I would just say, oh, I can pull the 2 out, and then I could take the value of the integral of f of x, which is 5, plus I could pull the 3 out and take the value of h of x, which is 7, because they've already done the area part, right? They've already found the integral. I'm just using the property. So it would be 10 plus 21, which would be 31. Questions on that? Now let's look at the bottom ones here. Let's find the integral from 0 to 1 of f of x. What do you think? What people want to do is say, well, if negative 1 to 1 is 5, 0 to 1 is half of that, so it should just be half of 5 or 2.5, right? People want to say that. But just because this whole area adds up to 5, does it mean that half of it is from 0 to 1 and half of it is from, oh, sorry, negative 1 to 0? Right, it doesn't necessarily mean that it's a symmetric thing. It could be, but we don't know. And so sometimes they're going to ask you things that you don't really know how to do. And so you have to really think about, do I have a property that says half of that is half of this? And it's not. So we have to say this is not possible to do. It could work, but we don't have enough information to say what the integral from 0 to 1 is. Same principle applies to e here. E negative 2 to 2, you think, oh, I'm just doubling this interval, so maybe I should just double 7 and the answer is 14. But again, we don't know that. We don't know what's happening on the outside of negative 1 to 1. Like, it could be a crazy graph and this side go way up and this side go way down. It could be no change at all. So we do not have a property that says we can double these and then double this. So this is also not possible. What about f? Can we do f? Negative 1 to 4 of f of x, we did that already. We can do that because we have the 1 to 4. But of h of x, we only know negative 1 to 1, which means we can't go to 4. So this is also not possible. What I've seen on like a multiple choice test is sometimes they'll say which one of these is not a property. And so you have to go through and think about which one do we not have a property to use. So like you'd have one of those bottom ones would be something like that. Or sometimes they just give you some integrals and they ask you a question. Like, if all this is true, then they ask you one of these questions and you have to just figure it up and it's just a number answer. Most of your homework today is this, which means it's not a lot of work. You just have to think about what properties you're using. And these properties will continue using over and over again. Okay? All right. He's very quiet today. No talking about how cute teachers are today. I think that's it. Okay, we did we have average value, mean? We had mean value for derivatives, right? Mean value theorem? You don't remember.
It sounds familiar. Yeah, mean value.
So average also means mean, so we can say this is average value or mean value. And it says if f is integral on a closed interval from a to b, its average value or its mean value on that interval is 1 over b minus a, because that's the interval, times the actual integral, which is the area. Think about what integral means. I'm going to kind of draw you a little picture here for a minute just to kind of show you what this means. Let's say I drew a little graph here. from A to B. And let's say I just broke it up. Like, remember that an integral actually means like infinite number of rectangles. We don't have that many rectangles. I can't draw that many rectangles. So I'm just going to like draw a few little rectangles in here. And let's just pretend that I'm going to do something like this. That would be like using my right endpoints, right? The average value would be if they averaged all the heights of the rectangle. So instead of thinking about all these different heights, if we just averaged it out, that's kind of what average value is, just to kind of tell you what we're finding here. So they're going to ask you questions like this. Find the average value of this function from 0 to 3, and does f actually take on this value at some point in the given interval? We did the exact same thing for mean value theorem of derivatives. Mean value theorem was where we did the derivative is equal to the slope of the secant line. Remember that? That was like f prime of c equals f of b minus f of a over b minus a. That says that the derivative will equal the slope of the secant line at some point. The average value is telling us, like, what would the average of all that be if we worked it out? All you got to do is know the formula. I just want to kind of show you where it came from. So we could say this would be 1 over 3 minus 0 times the integral from 0 to 3 of 4 minus x squared dx. I really want you to get in the habit of writing out what you're doing, even if you're not actually going to work it out, or even if you're using area to work it out. Get in the habit of writing out. On AP stuff, on the free response, a lot of times you get a point for writing it out. Even if you use your calculator, you have to write it out to show what you're typing in your calculator. And so try to get in the habit of starting doing this. We're going to look at some free response before we have a test over this chapter, just because we haven't really done it yet, so you can kind of see how Riemann sums and how all this stuff shows up on an AP test, especially since we're going to have, I think our test is going to be like an AP test. We have that button on our calculator, but I don't want you to use that button because we could we draw a picture? Oh no, we can't. I think we have to use a button. We don't know how to do this yet, do we? 4 minus x squared is a parabola, right? Yeah, we can't do this yet. If this was a square root, we would make a semicircle, but so we need to use our calculators. There is no average value button on your calculator, so it's why it's really important that you have to remember this 1/3. I'm okay if you want to type it in and then multiply by 1/3, or if you do it all at once, you could hit 1/3, and then you could hit function like math 9 and do it all at once. I don't care. I'm going to just write my answer here. So hopefully you're kind of getting good at this button now. Math 9, and then this should show up on your calculator. And then you type in the function. So you're just going to type in 4 minus x squared. You have to do comma x. Or if you were using a different letter, you have to use comma that letter, like if this was 4 minus y squared. And then you have to tell it the bound. So you have to do lowest bound, comma, highest bound, close your parentheses. And then if you can multiply by 1/3. I got 3. Did you get 3?
I got 1.
Well, then that's when you multiply by 1/3, you get 1.
I did that. Oh, okay.
Like if I did 1/3, yeah. Because that's the average value. So it's not just the integral anymore. We're finding the average of the whole integral. That's what
How can it be average everything? It's exact.
I don't know. I don't know how to answer that question. Let me get back to you, okay? I don't know how to answer that. It's still finding the exact value. Like this is still the exact area, but when you multiply by this in front, it's giving you something called the average value. And maybe it'll make more sense if we look at some free response questions to show you. Like sometimes we say we're totally not here yet, but sometimes we say this is like the rate of something happening. So like I was talking about like the rate of snowfall. We could say if the snow is falling at this much per hour over from 0 to 3 hours, if we do the average value, we can say that on average, 1 inch of snow fell per hour. I don't know if that makes any sense, but that's kind of like, we're not there yet, but that's where we're going with this. So it says, does f actually take on this value at some point in the given interval? Will 4 minus x squared equal 1 at some point? And you could just work it out. Will f of x equal 1 somewhere between 0 and 3? So can I just plug in 4 minus x squared equals 1 and do some algebra? Well, we got this negative, right? So if I subtract 4, you agree I get negative x squared equals negative 3. So the negatives would cancel out. So I get x equals plus or minus the square root of 3. This doesn't actually tell you to give the value, but sometimes it'll say, where does it actually take it on? Right. It's actually 1 at 2 spots, both positive and negative radical 3, but you have to make sure you're in the given interval. And so Sean says the actual time is only at x equals positive square root of 3, because that's the only one in the interval. So the mean value theorem said if you have a closed interval and a continuous function, that the average rate of change will always equal the instantaneous rate of change. And we can say the same thing about average value. So does it actually take on this value? If certain things are true. So if you go to the next page, it's the mean value theorem, right? This is not a theorem, what I just gave you. It's just a formula. And we say this is the MVT for definite integrals. Right? Instead of mean value theorem, you can shorten it up MVT. If f is a continuous function on your interval from a to b, then there will always be some value in the function c that's equal to the average value. And so just like mean value theorem, if it's continuous on a closed interval, then it will always be true. And again, we'll use this a lot more as we get into AP stuff and as we get into chapter 7, but I just wanted to give it to you today to show you that we can use it. Okay, so average value or mean value. You okay with that? The majority of your homework today is the property stuff, not this, but this is going to come back to us a lot. Okay, so that's it. That's my notes. See, we could have written all that out. We still have like 15 minutes. It's ridiculous. So 5-3 day 1, you're just doing these questions. 1, 3, 4, 6, 8, 10, 12, 14. Work on them. Maybe you can get them done. If you're not caught up on homework, make sure that you're working on that. And we'll do 5-3 tomorrow, worksheet on Friday.